All right, guys, welcome back to my series on making my house smart. And in the last video, I showed you guys how to publish and subscribe using a normal Python script right from your system to the MQTT broker. This time around, I want to do the same thing, but I want to do it from the ESP32 because our final goal is being able to subscribe and publish through the ESP32 and be able to get those information on our system or on the system that runs Sha-De's main program, and then do whatever automation we need to do. Now, before I dive into coding for today, I quickly want to show you guys a diagram I came up with that kind of explains what we're trying to do here. Okay, so I think at this point it might still be a little bit confusing, or the goal might still not be clear enough. So I came up with a diagram that kind of explains the whole system in a better way. So the link to this GitHub repository is on the description, so you can always come here to check out the codes. And for instance, I have the codes, all the codes that I'll be using in these tutorials will be under the tutorial directory in the GitHub repository. So if you come here, you can see some of the communications and everything, as you can see here. So the last one we did, the last code we wrote Sha-De.py and then device.py is here. So the one for this particular video will also be uploaded to this repository. So you can always come here for any resources you need. However, what I want to show you guys is actually this diagram I kept here, right? So like a flow of the entire system. All right, so if you take a look at this explains how the system is going to work. And let's start from the very top. So in order to make this thing easier and more organized, I've decided to group devices in the house into something called a node. So you can have 5 devices in one node. You can have 2 devices in one node, or you can just have 1 device in one node. So what you see at the top here that is labeled master room, sitting room, TV, office, camera, these are all single node, right? Now a single node means that there is one ESP in that group, one ESP, one Wi-Fi microcontroller in that group, or one Wi-Fi enabled device in that group. So for instance, now in this particular one here, we have the master room. Let me see if I can zoom this a little bit. Good. All right, so we have the master room, as you can see here. In this master room, we have 3 devices. We have a light bulb, we have a sensor here. This will be a gas sensor, a temperature sensor, whatever kind of sensor. So let's just assume this is a temperature sensor. And then we have the wall socket or an extension here, all connected to the ESP. So the ESP can control their states. When I say states, I mean their current. For instance, now the light bulb can either be on or off, which can be represented as 1 or 0. For the sensor, if it is a digital sensor, it can either be 1 or 0 also. So let's say it's a gas sensor. So 1 will mean that gas has been detected, and 0 will mean that gas is not detected at the moment. If it's a temperature sensor, then the state will be the value of the temperature of the city of the master room, right? So for this plug here, or smart plug, whatever you want to call it, it's going to have 2 states also, either on or off. So there are 3 devices in this group, which is a node that has 1 ESP. In the sitting room, we have the door lock, we have the curtain, and we have the sensor, right? Then we also have TV as a single node. We have office as a single node that has also the light bulb, the curtain, and then the smart plug. And we also have camera as a single node. Now, this represents the devices in the house that are grouped into various nodes, right? Now, each of these nodes has the ability to publish and subscribe values into the MQTT broker. Now, remember in the first video I explained the MQTT broker and I said it has to be running on the network, on the system, right? And we have that running. So each of these nodes can publish and subscribe the states of the devices in the group to the MQTT broker. So anyone that connects to this MQTT broker can now have access to those devices, either checking their states or changing their states. So For instance, if I want to change the state of the light bulb here, all I need to know is the topic in which this node is subscribed to, and from that topic I can send in the command to change the state of the light bulb. If I want to check the temperature of the master room, all I need to know is the topic that this temperature is being published to by the master room node, and then check the information in that topic, and that gives me the temperature of the master room. So that's how everything works, right? So for each node, there is two topics. There's a topic called command and there's a topic called log. So for the log topic, this is the topic that the node publishes to. So the value of the temperature will constantly be published to the log topic. So we're going to have something like master room / log. That's going to be the name of the topic that this guy publishes temperature to, right? And for the command topic, this is the topic that the node subscribes to get command, to get request, right? Like a request to change the state of the light bulb. So if I want to change the state of the light bulb here, all I need to do is to publish a value to the command topic, right? That says light bulb on, and then this light bulb comes on. So that's exactly what happens in the entire system. So each node publish and subscribe to command and log topic respectively, and the same thing applies to every other node in the network. Now all this information gets to the MQTT broker, I mean information on the log and on the command, and then we now have a microservice called Sha-De shell that connects to the MQTT broker. So basically, we don't want to come into this MQTT broker and manipulate things ourselves, right? We want a program to handle the communication with that broker. So that program is going to be written in Python, and it's going to be called the Sha-De shell. I can probably change the name later, but I feel that makes sense for now. So basically, as a user, you don't really you don't interact with the broker, you interact with Sha-De shell. And whatever you need Sha-De shell to do, right? Sha-De shell sends the right command to the MQTT broker, or publish the right command to the right topic in the MQTT broker. So, for instance, if I want to turn on the light in master room, all I need to do is to come to this Sha-De shell and then tell it to turn on the light in the master room, and Sha-De shell generates the right command for that, or finds the right topic that needs that information to be published to in the MQTT broker, and then publish that information. So in this case, the topic is going to be master room / command. So this will become more clear when I show you guys the coding. It's going to become much more clear and easy to understand. So we have the Sha-De shell that communicates with the MQTT broker to publish and subscribe values in order to change or read the states of each of these devices in each of these nodes. Now, but the truth is that even the Sha-De shell here, we are not going to actually interact with it directly. We're going to interact with it through different interfaces, right? 4 different interfaces to be precise. And these interfaces are also separate microservices. When I say microservice, I'm actually referring to a single Python script or a single Python program that runs independently. So it's possible that at a particular point in time, only the web UI service is what is running, while the other 3 services here are down. It doesn't affect the functionality of the entire system, right? The only 2 main things that need to be active at all points in time is the MQTT broker and then the Sha-De shell that communicates with the broker. Now, these Python programs here, the web UI service, the voice control service, the command prompt, and the AI automation service, is going to communicate through something we call gRPC. Now, I'm going to explain this in a future video, right, when we get to that point. But basically, it's just a communication protocol that's going to be used between these microservices here and this Sha-De shell. So let me start by explaining the web UI service. We already have an idea of what it's going to do. So the web UI service gives us a web interface, right, where we can type in commands or push button, drop down button, different kind of button, just something very nice interface, right? So if you want to turn on, let's say you want to turn the light on you want to turn the lights in the office on, all you need to do is just to go to this web UI interface, right? It's going to be like a web browser or on a tab, and then just look for that light and just press on, and the light comes up. So you press on this web UI, that command is sent to the Sha-De shell that generates the right, that Sha-De shell, basically what Sha-De shell does basically is to get the topic that it needs to publish that information to, right? And then also the right command to send to that topic. So after getting the topic and also getting the right command, it uses the MQTT broker to publish that topic and that's to that topic, and then with that right command, and then these slides can come up. All right, so for the voice control service, it does the same thing, but this time around, instead of using an interface where you press button, you use your voice. So something like Sha-De, turn on the room lights, and that turns on the room lights. For the command prompt, unlike the web UI service, the voice control service, the command prompt is basically another interface that allows you to type in your command. So if I want to turn on my room lights, I simply type turn on room lights. It's going to be like a WhatsApp chat. Yeah, it's actually going to be like a chat bot that you can chat with, right? So instead of using voice control or web UI service that gives you a button, you can have like a chat, right? So you can just send your command via chat or via a command prompt, just like you chat on WhatsApp, right? So like something like turn on my room lights, and then the command prompt takes that, pass that to the Sha-De shell, generates the right topic and command, pass that to MQTT broker. From the MQTT broker, the device that needs to be turned on turns on. And then finally, we have the AI automation service. Now, this is like a two-in-one actually. There are two things that happen here, right? And this is where the most advanced programming actually comes in. In this place, the two things are: one, this guy gets information from all the cameras in the network, right? And run face recognition and also emotion recognition or action recognition, right? And then once it does that, it keeps that information, right? So for instance, now let's say I have a camera in this camera is in, let's say the camera is in the entrance of my door, right? So if the camera sees my face, this guy, the AI automation service can sense that, right? And automatically, sends the command to open my door, right? So it sends the command to Sha-De shell. Sha-De shell sends the command to MQTT broker to open this door here. So this AI automation service, right? Unlike the web UI service, the voice control service, the command prompt, where you have to like specify what you want to do. For the web UI, you specify by pressing button, right? For the voice control, you specify by using your voice. For the command prompt, you specify by typing in the command. For the AI automation, it doesn't need you to specify anything. It just takes control based on some certain situation. Like if it says that I'm at the entrance of my house, automatically opens my door. So that's the first aspect of the AI automation service code, right? The second aspect is something I call scenes. Scenes. So basically, there's going to be a configuration file that you can edit right from the web UI service that basically says that it's like a if and then kind of condition. So we have conditions and actions. So if the time is 5 p.m., then turn on the sitting room light, right? So you set those scenes, right? And then this AI automation service use that scenes to make decision in the future. So let's say you set a scene that says that if it is in the morning, turn on my AC, right? You set that scene via the web UI. So this guy loads that scene, and anytime it's in the morning, it turns on your AC, and when it is in the afternoon, it turns off your AC. So two things: it checks your scene to automate devices in your house, or it makes decision based on what it sees through the camera. So that's what the AI automation service does, right? So we have 4 services for now: AI automation service, the command prompt, the voice control, the web UI, right? Those are the main services that we use to interact with the core of the system, which is the Sha-De shell. And Sha-De shell is able to, send the right command to the right device and also get the right information from the right device. So this is quite an advanced, I won't say an advanced, right? But this is a standard architecture that even applies to the view world, like view automation world. If you're actually working as an AI engineer or working as an IoT engineer with big companies, this is exactly, not exactly do, but this is like the standard of how things are done. So There are a lot of technologies that's going to apply here, but I'm only going to explain the basics, right? And then I'm also going to, most of the code will be available on the repository, so you can always go there and check the code. So just one more thing before I proceed to the coding for today. So if you check here, I have some list of commands. I might add to this command later, but for now, these are the commands that the Sha-De shell actually listens to. So here we have set. So set is used to set devices to a particular state. So if I want to turn on these lights in my master room, all I need to do is set master room light on, or set master room light 1. It comes up. Set master room light off, or set master room light 0. Now there is get command. The get command gets the state of the device. So for instance, if I want to know if my door is opened, right? The door in the sitting room is open, I can say get sitting room door, and then Sha-De is going to respond with door is open or door is closed. Now there's also the add command. The add command is used to add new devices or new nodes basically to the network. So let's say, for instance, you don't have, like for instance, if you check the list of the nodes here, we don't have anything that says bedroom here. Let's say I want to add my bedroom to these nodes. I'm going to use this add command. So I'm going to say add bedroom and then set bedroom children to light and temperature. Yeah, that's something I didn't explain. I didn't explain what children is. So another concept I came up with, right, it's called children. So if you come back here, I said this box represents a node. So each of these devices here are children of this node. So the light bulb here, the sensor here, and the plug here are all children of the master room node. So for this one, the smart lock, the curtain, and the sensor here are all children of the sitting room node. Now these terminologies are actually very, very important because I'm going to be using them while I'm coding. So if you want to follow along, you have to take note of these terms. Children are simply devices in a particular node. All right, so that is the add. The add is used to add new node. Then the remove is used to remove an existing node. Then the list. When you send the list command to the Sha-De shell, what it does is just to tell you all the devices that are currently in the network that are listening and publishing their values to the MQTT broker. So yeah, this is a very good picture of what we want to achieve. So right now, what we want to do in this video, what we want to do next is to program the code for the ESP that allows the ESP to publish and subscribe its values into the MQTT broker. So the same code applies to every node in the network with some slight difference, right? So once we achieve this, then we can move to the Sha-De. We already have the MQTT broker running already. So this is not the Python script we write. This is something that already exists when we installed Mosquito. So the next thing I'm going to do after this guy program is to write the program for Sha-De shell. Then we can now proceed to write these services programs here: the web UI, the voice control, the command prompts, and the AI automation service. I know that's a lot to take in, but that's a very good explanation of how the entire system is going to work. So let's dive into coding.